Hello, you are welcome to Royal Tutors, and I'm sure you've enjoyed our previous videos. And in today's video, we'll be looking at factors of a number, factors of a number. And standing here before you, we have Mr. Damilola. So let's continue into the lesson. Now, in today's lesson, we'll be looking at factors and how to find factors of a number. I say that again, factors and how to find factors of a number. Now let's look at the lesson objectives. So in today's lesson, you would be able to know the meaning of factors. You would also be able to use factor pairs to identify factors of a number. And the third thing is that you'll be able to list the factors of a number. So you will not just only know the meaning, but you will also know the factor pairs that helps you to identify factors of a number, as well as you'd be able to list them, the factors of a given number. Now, what does the factors of a number mean? What does the factors of a number mean? Factors of a number are identified or are defined as whole numbers that divide the original number evenly or exactly, that is, without remainder. So, for example, let's have the number 12. So, the number 12 is easily divisible without remainder by 3. So, therefore, we say 3 is a factor of 12. That is, 3 is a factor of 12. Now, let's proceed. These are the things you need to note when highlighting your factors or when listing out your factors of a number. You need to understand and to note these following things. Number one, a factor cannot be a fraction. A factor cannot be a fraction. So you need to understand that a factor cannot be a fraction. It cannot be what? A fraction. And number two thing you need to know is that what? 1 is a factor of every number. 1 is a factor of every number. 1 is a factor of every number. Also, the third thing you need to know is that what? Every number is a factor of itself. So 2 is a factor of 2. 7 is a factor of 7. 8 is a factor of 8. 19 is a factor of 19. 29 is a factor of 29. 48 is a factor of 48. 27 is a factor of 27. That is, every number is a factor of itself. And remember that we have two groups of numbers. We have prime numbers and we have composite numbers. Now you need to know that each prime number will only have two factors, as the definition implies that prime numbers are numbers that have just two factors, which are what? 1 and itself. 1 and itself. So as an example, 17 is a prime number. So 17 only has two factors, which is 1 and 17 itself. Then the other groups of number, we have composite numbers. So composite numbers, they have more than two factors. I say that again. Composite numbers, they have more than two factors. Composite numbers, they have more than two factors. For example, an example of composite number is 8. 8 has more than two factors. And what are the factors of 8? We have 1, we have 2, we have 4, and we have 8 itself. But don't worry, as we continue with this lesson, you will know how to generate the list of factors. As we continue in this lesson, you would be able to generate the list of factors for each number presented to you. Now, the method we'll be using to generate our list of factors is factor pairs. I'll say that again. Factor pair, that is the method we are using. Now, let's know what are factor pairs. A factor pair is a list of two factors which when multiplied together gives specific products. A factor pair is a set of two factors, that is two numbers, whole numbers now, which when multiplied together gives specific products. Now, what do we mean? For example, 4 times 7 is equal to 28. What does that mean? It means that 4 and 7 are factor pair of 28. Hence, 4 is a factor of 28 and 7 is also a factor of 28. So because 4 times 7 gives 28, so 4 times 4 and 7 are factor pair of 28. 4 and 7 are what? Factor pair of 28. So therefore, 4 is a factor of 28 as well as 7 is also a factor of 28. Now let's proceed. The method we'll be using to generate our factor pair is what I denote as CFC. CFC. What does CFC mean? It means continuous factor check. Continuous factor check. That is checking if each consecutive numbers can divide a particular number. For example, you start from 1, you go to 2, you go to 3, you go to 4, you go to 5, you go to 6, and so on and so forth. That is, you consider each positive number. If you want to generate the factor pair of 12, you ask yourself, can 1 divide 12? After you've answered the question, you go to 2. Can 2 divide 12? Then you go to 3. Can 3 divide 12? Then you go to 4. Can 4 divide 12? You continue until you get to a point, and don't worry, you will get to understand everything about generating your factor pair in this lesson. How to find the factors of a number. How to find the factors of a number. First step, start with 1. Start with what? 1. Remember that the first factor pair of every number are what? 1 and the number itself. That is, if you want to generate the factor pair of 12, you would have 1 and 12. If you want to generate factor pair of 36, the first one you get is 1 and 36. Why? Because 1 is a factor of every number and every number is a factor of itself. So we have 1 and 12 to be first factor pair for 12. 1 and 36 to be the first factor pair for 36. 1 and 99 for as the first factor pair of 99. So start with what? That's the first step. Start with 1. Afterwards, you proceed to test the next whole number, which is 2. So when you want to get a factor pair of 12, you started with 1. Can 1 divide 12? Yes, because 1 can divide every number. That is, 1 can divide every number. So after 1, you go to 2. That particular number you want to divide, can 2 divide it? If 2 can divide the number without remainder, then you write down the number, which is 2, and the quotient, that is the number of times 2 divides into the number. Let's take, for example, if you have the number 12, you already generate the first factor pair to be 1 and 12. So now you proceed, you then proceed into 2. Can 2 divide 12? Yes. How many times? 6 times. So therefore you have generated the second factor pair. So that is how it works. Now let's continue. What's the next step? You continue this process with the next whole numbers. So it's not just 1 and 2, but you also continue. So when you find a number that divides the original number without a remainder, write down the pairs of factors, that is the divisor and the quotient. For example, just as we're doing with 12. So we say 12, 1 times 12, 12 again, 2 times 6. Now, we proceed into 3. Can 3 divide 12? Yes. How many times? 4 times. So it is what? 3 times 4. So by 1 times 12, we got 12. 2 times 6, we got 12. 3 times 4, we got 12. So these are what the factor pairs of the number 12. Now let's continue. Can 4 divide 12? Yes. 4 can divide 12 3 times. Can 5 divide 12? No. 5 cannot divide 12. What other thing can divide 12? 6. 6 can divide 12 how many times? 2 times. Now, there is something you need to know, because if you notice, you will discover that we are already repeating some numbers, that is some factors. So when do we know when to stop? How do we know, and when do we know when to stop? And that is what the next step is telling us. The next step says that what? Stop when the divisor you're using are larger than the quotient you're getting. So what does that mean? In this case, our divisor is smaller than our quotient, which is 12. In this case, so this is valid. 2 times 6, divisor is smaller than quotient. This is valid. In this case, 3 is smaller than 12, that is, divisor is smaller than quotient. But here, our divisor 4 is bigger than quotient, so therefore we won't use this. Here, 6, our divisor, is bigger than our quotient, so therefore we won't use this. So that is how we know when to start and when to stop. So you stop when your divisor is greater than your quotient. So that is how it works. Now, let's take example. Our first example, example number 1. Find the factors of 12. So what are the factors of 12? Let's start with our first step. Our first step says what? Start with 1. So when we started with 1, we discover, don't forget that 1 is always a factor of every number, right? So 1 times 12, that gives us the first factor of 12. Then the next step says test the next whole number, which is 2. So 2 divides 12 how many times? 6 times. So therefore we have 2 times 6. The next step says continue this process with the next whole numbers. But guess what? Only 3 divides 12 without remainder and without any form of repetition. So we stop at 3 times 12. And it says stop when the divisor you are testing are larger than the quotient you're getting. So since 4 is greater than 3, so we have to stop at this point. So we have to stop at this point. This will not go with us because our divisor is already greater than the quotient. Therefore, it will generate repetition. So therefore, we stop at 3 times 4 for our factor pair. So let's list out our factor pairs now. The factor pairs of 12 are 1 times 12, 2 times 6, and 3 times 4. So let's list out our factors now. So therefore, our factors, that is the factors of 12, are 1, 2, 3, 4, 6, and 12. As you can see, they are generated from the factor pairs. Now let's get to another example. Example number 2. Find the factors of 15. Find the factors of 15. So we start with what? 1. So 1 times 15, remember, every number is a factor of itself, and 1 is a factor of every number. So therefore, our first factor pair is 1 times 15. Then we continue to the next whole number, which is 2. 2 cannot divide 15 without remainder, because when you divide 15 by 2, it will go, your 15 will be divided by 2 7 times with a remainder of 1. So because there's a remainder of 1, 2 is not a factor of 15. Then we continue the process with the next whole numbers, and we found 3 to be the next factor, which is multiplied by 5 to give 15. So 3 times 15 is our next factor pair. Now remember to stop when your divisor is greater than your quotient. So because 5 times 3 is also a factor pair, but 5, which is a divisor, is greater than 3, which is a quotient. So therefore we won't pick this. So we stop at this point. So let's list out our factor pairs now. So the factor pairs of 15 are what? 1 times 15 and 3 times 12. So 1 times 15 and 3 times 12. So what are the factors of 15? What are the factors of 15? So the factors of 15 are 1, 3, 5, and 15. 1, 3, 5, and 15. So the factors of 15 are what? 1, 3, 5, and 15. So let's continue. Another example, 28. What are the factors of 28? So we start with 1, as our custom is. We start with 1. 1 times 28 is the first factor of 28. Then we test the next whole number, which is 2 times 2 times what? 2 can divide 28. How many times? 14 times. So we have 2 times 14 to be our next factor pair for 28. Then we continue the process with the next whole number, which is 3, 4, 5, and so on and so forth. But remember, 4 can divide 28 7 times. And then we stop because 7 is already bigger than 7, which is our divisor, is bigger than the quotient 4. So therefore this will not go with us. So we stop here. So the factor pairs of 28 are 1 times 28, 2 times 14. So the factors of 28 are, deriving it from your factor pairs, you would have 1, 2, 4, 7, 14, and 28. 1, 2, 4, 7, 14, and 28. And these are generated from our factor pairs. So the next example is example 4. Find the factors of 30. We are finding the factors of 30. Now, start with 1. Remember, the first step is start with 1. So 1 times 30. Then test the next whole number. The next whole number is 2. So how many times will 2 divide 30? 15 times. So 2 will divide 30 15 times. Continue the process with the next whole number. So we know that what? 3 can divide 30 10 times, and 5 can divide 30 6 times, but 4 cannot divide 30. Also, you need to stop when your divisor is larger than your quotient. That is, in the case of 6 times 5. So what do we do in the case of 6 times 5? We know that what? 6 is already greater than 5. So this will not go with us. So we only take on 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So let's get the list of our factor pairs for 30. Is 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Now the factors of 30 are what? 1, 2, 3, 5, 6, 10, 15, and 30. And all of these are generated from our factor pairs. Now let's do our last example, example 5. What are the factors of 60? So generating our factor pairs of 60, we got 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 30. So 6 times 10, and 6 times 10. So these are the factors of factor pairs of 60. So with these are factor pairs, let's generate our list of factors for 60. So the list of factors for 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So these are a list of factors for 60. So we've come a long way. I think it's time to take a short assessment. Alright, so can you list the factor pairs and the factors of these numbers, 25 and 72? So pause the video and check your knowledge. Are you able to list the factors of 25 and 72? Let's take a check. You're welcome back. So now that you have done your list of factors and factor pairs for 25 and 72, check. Are you correct? Check. Are you correct? So if you're correct, a round of applause for you. And if you're not correct, keep on practicing. With time, you become better. Now let's look at the summary of today's lesson. The summary of today's lessons are: factors of a number are defined as whole numbers that divide the original number evenly or exactly, that is, without remainder. Also remember our CFC, which is what? Continuous factor check. That is, we continue to check until we are able to generate our what? Factor pair and our list of factors. Remember, the steps are: start with 1, text the next whole number, continue this process until the next whole number after 2. Then stop when your divisor is greater than your quotient. And I believe you've learned something great into this lesson, and have a great time. You can check more of our videos to learn more on other concepts in mathematics, and I'm so sure that you would enjoy our lessons. All right, bye.